So what I'm going to do today, this talk, like the proverbial football game, is a talk of two halves. The first half is based on a paper on algorithms and what it means to take the algorithm as an object of sort of sociocultural analysis that I published last year. This second half of the talk, it's much more speculative, and it's really just like a few slides with a few words, and I've got no idea yet what I'm going to say to them. But I wanted to also talk about a new project that's been going on just for a couple of months, an ethnographic project that I think and hope would be of interest to you. So the context here is that, this kind of weird thing, right? So I was trained for undergraduate as a computer scientist. As an undergraduate computer scientist, you spend lots of time talking about algorithms, but you don't expect them to be the sorts of things that are talked about on the front page of The Guardian, The Scotsman, or The New York Times. But suddenly, in the last couple of years, as you will be familiar yourself, there is all sorts of public speculation about algorithms and their role in our lives, from the serious and significant consequential issues about job loss, from concerns about bias around criminal sentencing, access to financial services, or even the forms of bias that apparently govern the use of air conditioning systems and our differential experiences of them. And as you also know, there has similarly been within the science studies literature and other research domains an equal interest in the role that algorithms play and how they are starting to infiltrate their way into sort of questions of governance and so forth. So actually, a couple of years ago, went to a really interesting conference at NYU, specifically entitled "Governing Algorithms," focusing on what it was both how algorithms were being deployed in support in situations of governance, and also how we might wrest control back and ourselves understand, confront, and govern algorithms. You may be familiar with writings of people like Frank Pasquale and Lev Manovich and Charlton and others. And one of the things, my job at that conference was to do this thing that I always seem to keep getting asked to do, and I hate to do, which is like I had to be the person to somehow synthesize and summarize everything that was said, and also be amusing enough to prevent people from going to the cocktails, which was the next thing we were meant to do. I'm so glad you didn't ask me to do that here. And one of the things that I mentioned at that meeting in my closing remarks was the confusion that it seemed to me to attend the word algorithm when the algorithm was their object of attention. So what was it that people had in mind when they spoke about algorithms, when they identified algorithms as the things that they were particularly concerned about? You had this sort of like generic idea that they were somehow technological, they were procedural, but it's sort of like, they were really just being sort of caught up in this sort of larger master narrative, because there was always an implicit, it used to be done by some other means and now it's done by an algorithm, and this sort of notion the algorithm is fast, whereas whatever else we did or used to do or might be able to do is slow. The algorithm is automatic, autonomous, whereas some other alternative procedure would be monitored and have a sort of a human in the loop. So it's mechanical, mechanistic rather than human. And most particularly this problem that somehow human processes were inherently inspectable. They were open to scrutiny and examination, and many of the anxieties around the algorithm are to do with its inscrutability, with the inability of the algorithm to account for itself, or our inability to account, either through a sort of technological obscurantism, or because it's just moving too fast, to be for what it was that the algorithm was doing. But But the problem that I sort of raised at that point was that, you know, while, okay, I can sort of understand how this sort of master narrative works, and I understand how the algorithm is being imagined here to be an other to human and organizational processes, there's still not a lot of particularity to what the algorithm means. Because when I sort of think about those things, I can apply them in many different, or think about that narrative, I can apply it in many different kinds of ways. So, you know, one thing is that, what does it mean then to talk about an algorithm rather than to talk about code? What does it mean to talk about an algorithm rather than software, right? And so, you know, if you've been tracking what happens in software studies, or Mark Marino's work in like critical code studies and things, you know, we can see the emergence of the algorithm as a site of analytic attention as arising, you know, in the context of and in response to, but in differentiation from what it is that software studies has been doing, what it is that critical code studies has been doing. And I'm kind of intrigued as to that distinction. And the question really in some ways is whether this is a distinction that matters for people doing algorithmic stuff. That is, when a bunch of people stood up at that conference and said, we're interested in algorithms, did that mean they were interested in algorithms but not so much in code? When you start to think about this relationship between algorithms and code, we find a number of sort of like interesting properties. One is that algorithms can't be simply read off code. I can give you the code, and yet the algorithm isn't necessarily transparent or straightforward. If the algorithm is some kind of generic procedure that gets enacted by a piece of code and a piece of software in a computer, there's a notion that somehow the algorithm has been reduced to code, but that doesn't actually mean that you can adduce back up to get the algorithm off the code. For a start, code has to do a hell of a lot of stuff that's not in the algorithm. Code has to do all sorts of things. Algorithms don't have to worry about running out of memory. Algorithms don't worry about whether or not the disk is full. Algorithms don't worry about whether an operation can be performed quickly enough to give you a response within the time that you want. And algorithms don't worry about mouse pointers and windows and the other kinds of things that code does need to worry about. And so the algorithm and the code are really quite different. The production of the expression of an algorithm in a piece of code or one piece of code or another piece of code is going to vary considerably. In different programming languages, the algorithm is going to manifest itself as a piece of code quite differently. And the reason, again, I want to bring up these distinctions that might seem abstruse, or perhaps the kinds of things that could only matter to someone with an undergraduate training in computer science. But the importance of them is that the algorithm is not something that we encounter. If we're concerned about algorithmic governance, nothing is governed by the algorithm, because the algorithm isn't actually the thing that's doing the work. And if, again, my concern is if what we adopt as an object of analytic attention from a sort of STS perspective, from a communication perspective, or under the umbrella of what's typically now called critical algorithm studies, the question is, what is the thing that we're looking at, and where can we identify the phenomena? But code, it turns out, isn't the only one of those things. Code certainly is one of the things that we might be capturing when we talk about algorithms. But frequently, the notions that we sort of focus on when we think about the algorithmic are to do with architecture, are to do with the ways that multiple different kinds of components inside or across multiple computer systems are brought together in order to represent the world as something that can be operated upon. So when we start to think about architecture, we start to think about connections, we start to think about protocols, for instance, right? The things that connect and allow different elements within a system to talk to each other or prevent them from talking to each other. And again, here we find this sort of complicated relationship to the algorithm. The algorithm, when we start to think about it in architectural terms, algorithms are often smeared across different elements of a computer system. If I want to find particular kinds of algorithms on the network, I may find that it doesn't work, it can't be located in any single place. If I want to find the congestion control algorithm for TCP/IP or the slow start algorithm, I can't find it in any one place because little bits of it appear in all these different kinds of, in these different places. And yet, again, these are the kinds of things that I can empirically inquire into. These are the kinds of things that I can get hold of, that I can find lying around in the world or within the activities of computer programmers. These are the things that we actually attend more to in a sort of empirical level. Sorry, I'm looking at my notes and realizing there's this other thing I forgot to say, but I'm going to say it for the next. So okay. So we might. There's algorithms. We need to sort of think about where algorithms live within this space. There's algorithms in code. There's algorithms in architecture. There's algorithms and running systems. And again, I find it intriguing that we've had a sort of like the current conversation has placed algorithms at the center of our sort of analysis and displaced such things as actual running processes and actual running computers and the sorts of things that we've had in mind as we've tried to understand the sort of concentrations of power, the movement and locality of computational action. And in fact, when we start to think in terms of locality again we sort of find this thing that the algorithm may not actually happen all in one place, and that what's brought together in one place is much more than an algorithm. Not only does it come with all sorts of constraints, as I was mentioning earlier, but the embodiment produces a world of possibilities. There's an example I use at the beginning of the new book, which is around nuclear weapons testing, and you might be familiar with some of the with some of this, Hugh Gusterson's sort of writings on the topic, right? But given that we haven't blown up any nuclear weapons for a long time because of test ban treaties, the site of weapons testing and development is inside things like this, right? It's simulation inside computer systems. And the interesting sort of thing then is like, if once upon a time the material constraints upon the development of new kinds of weapon systems was the availability of fissile material and our abilities to process it and manage it, to find it and refine it, there's an argument that the material constraints now upon the kinds of weapons we can develop are the simulation capacities of large-scale computer systems. And that as new kinds of simulation technologies become available to us, and as new kinds of computational systems become available to us, what it is that our algorithms, our testing algorithms, our simulation algorithms can do manifestly and materially changes. New capacities that become available even within exactly the same algorithmic framework. The basic algorithms that we use for simulation, what are called Monte Carlo simulations, were laid down in the 1940s. We're using the same algorithms at this point, but they're able to do materially different things for us because of their embodiments here. And so again, a sort of focus on algorithm problematically displaces the actual materialization that shapes and conditions what it is that algorithm can be doing for us. So I think it's important in this sort of context of algorithms and algorithm studies to be able to draw these distinctions. And again, I recognize that they may seem like very fine distinctions, and indeed people like Wendy Chun have warned us again about the dangers of fetishizing various kinds of technical objects, to fetishize the source code and place a lot of attention there, or indeed, in this case, perhaps the algorithm. But I think it's still important to do, and it's important for a couple of reasons. Perhaps the dominant one of which is sort of an ethnographic accountability, if you will. That is, if I want to work with people who are in the business of developing algorithms, if I want to work with people who are in the business of deploying algorithms, if I want to work with people who are building these systems and for whom algorithms are a sort of part of everyday speech, then I think it's sort of important that I recognize that algorithm's a member's term. It's not simply my term that I can like pick up and adopt and use in any way, but if I want to be in conversation with them, then I want to be sort of recognizing the limits and the bounds on what it is that the algorithm does. And to recognize that, especially importantly actually, that in the development of software systems and or large-scale computational systems, not only does not only are there lots of things going on that are not the algorithm, but so I need to be able to distinguish between sort of things that are purely mechanistic and things that are algorithmic. Not everything that happens in the computer can be summarized by the name under the name algorithm. There's lots of other bits and pieces that have to sort of go on. So I do think that although these distinctions may seem somewhat persnickety. Not a word I normally use academically. I think about it. It's sort of ethnographically important, and if we want to be able to intervene in those conversations, it becomes even more so. So, we talk a lot about black boxing in our world, and certainly when we talk about algorithms, the black boxing of algorithmic processing is important. But I'm sort of arguing that we're sort of black boxing the notion of the concept of what an algorithm is in the first place. But I do want to talk a little bit about this sort of this concern about how it is that we get to see into that box and see what's going on in algorithmic systems. And again, I'm going to sort of work my way back around to a sort of an ethnographic concern, which is more where the second half of my talk is. So people like Frank Pasquale, whose book Black Box Society I referred to earlier, and people like Tarleton Gillespie and others have argued for the importance of us to be able to account for or call algorithms to account and algorithmic systems to account, to understand what it is they do, and to be able to inquire into the potentials for bias, for discrimination, for other sort of like randomly encoded things that might otherwise be invisible to us, for making an algorithmic world accountable. And Jenna Burrell from Berkeley had a really interesting paper that she published in Big Data and Society a year before last, I think. Setting out some of the ways in which this may be simply infeasible, the multiple different sources of algorithmic opacity. Some which, and this is sort of particularly in response to that notion that there's an important strategy that we need to be imposing upon algorithmic systems, that they become accountable. And she details a number of different kinds of things, right, that are inherently limits upon the visibility or translucence of algorithms. So, and one is simply the problems of trade secrecy. That most algorithms are owned by corporations and are critical intellectual property for those organizations and aren't likely to become visible to us in any short term. One could imagine a whole series of ways in which you could address that as a sort of legislative issue. The second is clearly the kinds of technical expertise required to go and examine algorithms, what it takes for somebody to be able to examine. It's like, Google could open up their code, but if Google has written it in their own programming language and they have several of those that nobody else uses or nobody else is terribly interested in, or even if it's in a conventional programming language, it's one that's only available to, or as its form of expertise only available to people who are appropriately trained. But of course, the most difficult issue is the fact that most of the algorithms that we normally have in scope when we're talking about the impact of sort of large-scale data analytics and the rest of it are machine learning algorithms that are sort of like pattern matching over large data sets. And the problem here is that the algorithm does not itself explain action. The algorithm is something that acts upon data, but in ways that are somewhat unpredictable. Let me give you this example that I take from Tarleton Gillespie. So, during the Occupy Wall Street movement, there was an issue that arose where people claimed that the movement was being censored by Twitter. And the reason was that the OWS hashtag never became a trending tag, never became a trending topic on Twitter. And it produced genuine moments of severe ontological doubt over how could Justin Bieber's haircut be a trending topic but not Occupy Wall Street? And fair enough, I'm with them on that one. But now it has to be said that Twitter does not have a good corporate history here. They've engaged in all sorts of acts of censorship in support of their advertisers. But they did claim, and most likely a genuine claim, that they did not engage in such an action with respect to Occupy Wall Street. The problem is that nobody, including the engineers at Twitter, can explain why something becomes a trending topic. They can tell you the algorithm, they can show you the algorithm, they can show you the code, although they won't, they could tell you the formula, although they won't, but we believe that they could, but that doesn't matter. Knowing the algorithm doesn't tell you what's going to happen. Because the algorithm operates over this teeming mass of data that's changing all the time, and you can never step twice into the same data stream. So it's you will never be able to sort of recapture the circumstances under which something happened. But more to the point, what the algorithm does is not identifying trending topics, it's identifying the kinds of things that maybe under certain circumstances could be like the same things that happened last week, and we decide that those are going to become trending topics. And so what it identifies are features, but not topics. It identifies properties and conditions, but not outcomes. And so they're not in a position to be able to account for why something did or did not become a trending topic. They can suggest perhaps, but they don't actually know. So that's one of these sort of aspects around the problems of opacity here, right? And this is a sort of disconcerting thing in some ways. When I again was an undergraduate computer scientist taking Stuart Anderson's computability class in some windowless room in JCMB in the buildings as it was back in the day. And to have an algorithm was to have an answer. An algorithm was meant to be something that would definitively produce an answer, an explanation. And if you've seen The Social Network, there's a point where the Mark Zuckerberg character asks Eduardo for his algorithm for doing ranking from chess. And the idea is I've got something, there's something I don't know, the algorithm will be a definitive procedure by which I can know. But that's not what we have with these kinds of algorithms, because what we definitively get out of those algorithms are clusters. We have got a definitive procedure by which if I take a bunch of data, it can say there's a cluster here that's, these things are more related to each other than any of them are to those things over there. But it can tell us nothing about what those are. Those all come from us. So I always like to argue that with big data, there's two scalar moves in so-called big data, right? The first is the massification move, the move from a single individual data item to a enormous set, right? This idea that, I'll take, my step count for the day, but I'll be able to put it together with other people's step counts, and now I'll be able to tell something about where I stand with respect to the whole. So that's the first massification, right? The move from small to big, from me to a collection. But the other really important one, which is the one that we sort of are actually experiencing, and the one that is the sort of problematic source of algorithmic concern, is the move from big back to small. That is, it's one thing for me to be able to say, look, there's a cluster here, and another thing to say, and this is dual income families in the Cincinnati metro area who are currently in the market for a new car, right? Which is that's sort of the promise of data analytics, is to be able to identify such things. Which such things being, as we're sort of familiar, right? Only ever the kinds of things that we knew we could have imagined there being in the first place. I didn't know there was a group for dual income families in the Cincinnati metro area in the market for a new car, but I knew that that's the kind of thing that I could have found. And so when I see that cluster and I need to find a way to identify what that is, and I click around and look at these items, it's oh, I'm finding the kind of thing that I could have found in the first place. So one is, this process of narrating the data, of reading back off it, those kinds of things that we always knew were potentially there, the kinds of things that we expected to find, is not itself a data or an algorithmic an algorithmic process. So I guess what in the paper that I published last year in BDNS, I was sort of arguing for then is to give us some of the foundation for a more ethnographic investigation of what algorithms might be and how they operate for people. And actually, Nick Seaver at Tufts has been doing some nice work along this direction, starting with recommendation algorithms in the music domain. But the question for me in some ways is, how do people produce, in the course of their daily work, produce the kinds of things that we might, or that they call algorithms? And how do they distinguish between those things and the other things that live as part of the sort of furniture of the electronic or computational world, but that are not themselves blessed with the name of algorithm? One of the things about algorithms, if you again get trained on them by somebody like Stuart, is that algorithms have names, right? They're particular individual things. There's Warshall's algorithm and Dijkstra's algorithm and any number of other kinds of, some of them have names for people and some of them have names like quicksort and fast Fourier transfer and things like that. They're sort of named, there are different kinds of names than the individuals who invented them. But there are those things that are algorithms, or nameable things that we can point to, and then there's all these other kinds of things that are part of computational systems that live outside of that label of algorithm. And I think a model here might be Eric Livingston's work on mathematics, a sort of ethnomethodological study of mathematics he conducted in the 1970s. And for Livingston, the focus was on proof. What's the sort of lived work of producing mathematical proof? And like algorithms, proofs have this ostensive property of being fairly sort of mechanistic, right? They're simply the application of a series of rules of transformation of mathematical, of one mathematical formula into another. And yet, as he points out, if you were to turn up in a math department and you were to write a proof on the board, and you were simply to go, well, x equals y, therefore x plus 1 equals y plus 1, therefore x equals y, therefore x plus 1 equals y plus 1, right? Which is entirely mathematically, formally correct. They would nonetheless cart you off and stick you in a straitjacket. You certainly wouldn't be doing math, right? That's not the kind of way in which you're meant to do these sort of formula translations. And in a similar kind of way, I think, they're looking at the lived work of algorithms, the production of algorithmic objects at the sites at which they're actually being done and deployed seems like an important thing to be able to do. I would like to that the second half of the talk was therefore about my doing it. It turns out not, but we'll get there in a second. The other thing that I think getting a sort of more refined focus on algorithms would allow us to do is track their movement. And I think this is a sort of really important part of this as well. So not only what produces things that people are prepared to label collectively and consensually as algorithms, but then to be able to track how those move around in the world. Because this, I think, is another problem that we're facing with respect to a lot of the algorithm work. That is, on the one hand, that people talk about, for instance, the Google algorithm, right? Either its search algorithm or its suggestion algorithm. That's an algorithm that changes on a daily or multi-times a day basis. Algorithms, those algorithms move around a lot, right? And we don't have good ideas of what the identity conditions upon those algorithms might be. And at the same time, I also actually want to track the places where the same algorithm moves around, gets redeployed in new contexts, in new systems, in new architectures, and then becomes a different kind of object. And then thirdly, something that will help us get towards the sort of like the dynamics of algorithms, of their movements, again, of their evolutions, and their evolutions alongside the kinds of embodiments, right? So this is going again to that example of the nuclear weapons testing, nuclear weapons simulation, that is that we sort of like focus on algorithms, does not allow us with the precision that I think we need to sort of focus on some of these questions. Okay, so the goal was, so the argument in that paper, this is where we're getting to the talk of two hats kind of thing. The focus in the paper was to try to set out the conditions for a more adequate sort of conducting a more adequate sort of ethnographic focus on algorithms. And so what I want to tell you about now is some of the ethnographic project. But it turns out the ethnographic project has, at least so far, not really been about algorithms, but it has been about data. So I want to tell you a little bit about that. Part because it's it's certainly strongly connected to the algorithm stuff, but hopefully also just some interesting things to talk about. So one of the big sites for these kinds of large-scale data analytics is urban management and urban governance, and all the narratives around smart cities, around the idea that data about and from the city can be a site for citizen involvement and a site for sort of civic participation is a narrative that we find all over the world at the moment. Certainly being driven by large corporations, but also being driven by but also sort of on the lips of many city managers, governors, and mayors, and so forth. And so for the last 8 months or so, my PhD student Leah Horgan has been ethnographically embedded with the data team of a large US city, which since I'm on camera, I will see no more. Leah's training is in graphic design originally, and when we were negotiating access to this group, we discovered that they were very much in need of a designer, someone to help them with visualization. To such an extent, and many of you may be familiar with the problems of gaining ethnographic access, and we were having a lot of problems with this for a while. That is, it took us several months to be able to even get on the data team leader's calendar and not get knocked off again. When Leah finally walked through the door to say, hey, this is what I want to do, the answer was no. We were afraid that this would sort of indicate this difficulty we were having was indicating that they weren't terribly interested. But in fact, what happened was the manager said, yes, absolutely, and can you come to this meeting in 5 minutes? Meantime, there's your desk. And so what she thought was just like visiting for half an hour to like set things up, and maybe she'd come back the next month. Turned into like being on the team as of like day one. Fortunately, she had an empty calendar for the afternoon. So the data team is a team of variable size, but generally round about 4 or 5 people, that operates inside the mayor's office of this large city, and which is responsible for multiple different kinds of programs, but in particular open data initiatives. That is, the movement of data sets from inside city government to places where the public can access them, with whatever kinds of anonymization and cleaning and standardization has to happen in order to do that. Encouraging different units of the city government to work together with the data that they have to establish a series of standards and so forth. And also actually responsible for liaison with all sorts of community groups who either want data or are interested in the production of apps and other things that make use of the data in order to improve the lives of citizens or explore particular kinds of issues or concerns, health, pollution, environment, and so forth. So they spend a lot of time organizing hackathons, and they spend a lot of time liaising with other groups, for instance, Obama's National Day of Civic Hacking and other kinds of groups that are embedded in different kinds of universities who are interested in doing some of this stuff. So we've been trying to track this stuff for the last 8 months with a focus on the work that makes data work, and just what it is in practice for people to be engaged in the potentials for sort of analytics. So let's see, how do I want to think about this? So they're called the data team. I think I can take each of those words and sort of think about it for a minute. Team is a kind of interesting word here. As I said, the team has a variable size, generally around 4 or 5 people. But only about 2 of those are actually employees. The team consists at any given moment of a remarkable number of people, actually like Leah, you know, she's my PhD student, I'm paying for her with grant money to be there, so she's essentially on a fellowship from me. Other people there are on fellowships from the Rockefeller Foundation, from the Ford Foundation. They are graduate students at other big universities in the area. There's an awful lot of making this work with A, with minimal numbers of people, and B, with volunteer labor. And actually, when I get to the next slide, I'll get into some more of the reasons for that. But the notion here of what the team is, even for something that is so prominent as part of the city's discussion and the city's self-conception, is really sort of like complicated. Data is an interesting kind of question as well here. The data team doesn't itself have data, because the data team doesn't really do very much. Maybe there's data about what the data team does, and that was an interesting kind of meta question. But the data that the data team is responsible for managing, massaging, and making available comes from the parks department, the parking department, the sewage department, the police department. Not education, actually, because in this city, education is a different function. But it's to do with the city, with the existing institutional structure of the city. So, which again, I'll have a little bit more to say about it in a moment. But the point is that there's a very interesting kind of they don't really own any of the data, right? But they do own all the visualizations, and they own all the technologies by which that data becomes available. And so actually they spend a lot of their time not really working with data, but it's very important with them to communicate through data. So they're actually in some ways more invested rather than in the data, in visual productions of that data, visual versions of that data. The last word that turns out to be interesting on this slide, by a process of elimination, you can probably guess, there's only 3 words on the slide, is the. They are the data team. There's a lot of people who want to be speaking with data and for data. Because there's a lot of interest in data, there's also a lot of interest in being the data people. And so although this group is constituted as the data team, within the larger infrastructure of the city, there are many others who would like to be seen to be the data people. The data team folk were really pissed off one day to come into the city hall and discover posters around for the Data and Donuts meeting, which was now to be held on, I don't know, the 3rd Thursday of every month, hosted by the IT organization, which is not the data team, and it's a completely different part of government that has completely different kind of functions, but for whom the word data is very important, right? As a sort of like, not just as a sort of like legitimizing thing, but also as a way for them to re-establish themselves at the hub of what is going on inside the city. And this organizational infrastructure kind of issue is really interesting here. The data team, as I said, is in part of the mayor's office. And like many smart city initiatives and open data initiatives, this is a mayoral initiative. The mayor ran on a ticket which included as a central element the idea of open governance and like high-tech operation. But the mayor, I mean, mayors are term limited for a start, right? So the mayor will have a maximum of 8 years. This is a very popular mayor. Everyone expects him to run for governor at some point. So the mayor's office is a bunch of people that he brought in, but that then have to operate with, what did I say, the parks department, the parking department, the sewage, and the rest of it. Most of which are run by people who've been there for 25 years, who've seen a lot of mayors come and a lot of mayors go, and have a great deal of organizational discretion about how responsive they want to be to the requests for new ways of working that come from somebody that they know if they just like wait around long enough will go away. And so the data team find themselves in this very sort of complicated kind of place, that is to speak for data, to speak about the city with data, means that they need to depend upon an effective organizational infrastructure in order for that to happen. And the structures that are available there very much condition the kinds of flows of data around. These people all have existing ways of working, all these different parts of the city have existing ways of working. They work more or less with each other, more in the less than more often less. And they often actually have their own IT infrastructures as well, and so part of the idea about trying to make data interoperable and make data public is actually dealing with the potential or limits of interoperation of their software systems. So whereas we imagine data to somehow be like underneath and all these other functions to be built on top of it, to be the data, to be the infrastructure here, the data is actually the sort of effervescent outcome of all these other kinds of like infrastructural relations. So the data then, essentially has to be sort of seen as part of a political project. And this again, we can sort of begin to see the hints of this in the organizational aspects of putting the data team in the mayor's office, which is a political office, not an office of city government, although they are, city employees, but they're not quite civil servants in the same sense as the director of the parks department. They're not civil servants in the same sense as the people who work within the police department to sort of like maintain records of crime and cleanup rates. For them, the part of the issue is, since they report directly to the mayor and work for the mayor and work in his office, they need to help the mayor look good. And helping the mayor look good means helping the mayor to clearly fulfill his promises. And the promise to make data available is a political promise, not a sort of like civil promise in some sense. The other thing that's really interesting when we sort of take that, moving on from that, is this idea that the people who run data for the city are people who, up until a couple of years ago, and up until the election of the mayor, were outside of the city banging on the doors saying, we need sunshine, we need transparency, we need access, we need to be able to see what this government's doing, we need accountability, we will gain accountability through access to the data that we know is locked up inside all of those different kinds of city units. They're activists. Now, of course, they find themselves inside the organization, working as part of the city, with still the same agenda, but now a recognition that while they want to make data available, they can't do it in a way that screws up the operations of government. They can't afford to piss off the police department. They can't afford to upset the people who are doing river reclamation stuff. And so they need to find a new way to harness or to express their activism. The concept we found useful here comes from Deborah Meyerson in particular, but along with a bunch of other people, who writes about the problems of tempered radicalism for people in different kinds of organizations. I was thinking of it during Neil's talk earlier because Meyerson was, maybe still is actually, a professor in the business school at Stanford. And her initial papers on tempered radicalism actually come from a very deep personal place, which is just, what does it mean for me to be a feminist progressive and work in a business school? Just how does that work? This is clearly like this deep angst. And so she comes up with this notion of tempered radicalism. How is it that people working in organizations that are apparently antithetical to their firmly held beliefs nonetheless find ways to, through small wins and small strategic efforts, prosecute those values even inside those kinds of organizations. And it's a useful model for trying to understand what's going on with the data folk here, who, as now that they find themselves working inside the city, realize that the kinds of things that they were always the advocates for and the kinds of things that they would really like to see are simply not practically achievable, nor are they likely to be to turn up anytime soon. So, as I said, we've been there for, I'd like to give you a sort of, super detailed, worked out thing, but we've been there for a few months and it's not done yet by a long way. But we are sort of trying, taking this idea that I was sort of saying earlier about trying to resituate these technical notions and make them available for ethnographic scrutiny, sort of looking at these processes of data work, which includes, or which is actually by and large then organizational work. The organizational work of making data operate, of finding things to, making things into data, And also, interestingly, looking at the work that data as a label does within sort of like in the competition between different parts of the city government. And so what we're I mean, it's no surprise that it's a messy process. It's no surprise that there is competition over these things. It's no surprise that the data doesn't always speak unequivocally. What we are finding especially interesting, though, are this sort of balance between sort of organizational concerns, broad political concerns, and personal sort of like advocacy concerns that are all sort of like the foundations upon which something that is so notionally pristine as the data actually sort of sit. So as I said, talk of two halves. The algorithm stuff is stuff that was published in a paper that Robin referred to me actually emailed me in the first instance. But I wanted, since we're in a sort of quiet and discursive place, to also give you some new stuff that is where this stuff has been going for me lately. So I haven't entirely been keeping track of time, but I hope we have some time for.
Excellent. Thank you very much.